Good morning, everybody. I'm Tom Girsch. For those of you who don't know me, I've got about a 30-year now, believe it or not, IT career. About 28 of those in total, working with databases and Informix in particular. This morning's presentation, it's one I've given a couple of times before, but it's a subject I feel pretty strongly about. Getting serious about redundancy. A little bit of housekeeping first. For everyone's information, because it's the only machine that I have that has a webcam, I'm on a laptop with a single screen. So unfortunately, as you have questions, please feel free to type them in the chat and they'll be relayed to me, but I will not see them until probably after the presentation is over. So just have some patience there with the questions. And I'm going to go ahead and I'm going to dive right in. So I'm going to start this off. First of all, I'm going to say that although the title they gave is Getting Serious About Redundancy with Informix, and it does indeed focus on Informix because that's our primary production environment, most of the concepts that you get in here, almost all of them, apply to pretty much any enterprise database system. So you don't have to be an Informix user to get a lot out of this. So I'm going to start us off here with a spoiler. This is, from the Informix point of view, what a really good redundant environment might look like. And I'm going to go into the details of what all of this means. So don't worry if this kind of looks like gibberish to you at the moment. We're going to break this all down as we go. So the first question, of course, why be redundant in the first place? Well, obviously minimizing downtime is hugely important. If you're in a 24/7 business like we are, or pretty close to it, every minute you're down is a minute you're not able to make money. You of course also want to prevent data loss as you can, because that's catastrophic for most enterprises. The ability to actually glom onto that redundancy to let you distribute your workload is a nice bonus. You can actually gain some performance benefits by distributing the workload across multiple nodes, and so it's a nice side effect of redundancy. And then finally, this is a theme that I'm going to hit on a lot as we go through this presentation. Things, in scare quotes there, things fail. I'm going to hit on that a lot because what is a thing? Well, lots of things are things, and we'll get to that. We'll discuss that a little bit. Of course, it doesn't come without costs. So some of the downsides of redundancy is that when you create a redundant environment, it's considerably more complicated. You might argue it gets exponentially more complicated with every node or set of nodes that you add. And of course, it's vastly more expensive than just running a single node. And one of the other things we're going to get to is that you solve a bunch of problems, but you also introduce some with redundancy. And we'll get to some of that too. I'm going to cover a lot of that in some real world examples of things that I've actually encountered over my decades long career. So my misfortune becomes your cautionary tale / hopefully lesson for you to improve your environment. So this is the mantra that we're going to talk about all throughout this presentation. Eliminate single points of failure. Things fail. They fail all the time. They fail in unexpected ways. So if you can think of a thing that if this thing breaks, everything is down or a large portion of things are down, that's a thing you need to worry about. And you need to try and figure out how to make it redundant, how to give it a backup, and how you're going to handle it if that thing in fact fails. So we're going to start at the host level, simple basic level. If you have multiple CPUs in your host, that's a good start. And not all hosts or hardware or platforms will survive the loss of a CPU, but especially with modern operating systems, most will these days. So rather than having the machine go completely down, you'll be running, but at a reduced capacity. And so that's helpful. Always oversize, more memory than you need, because again, you might have a memory chip go down. And like it says here, most modern hosts can disable a failed DIMM and keep the host running, a memory module, if you're not familiar with that term. So if you have a lot of memory and one of your memory chips goes bad, the system can keep running and just at a reduced capacity again. Here's where we get into some things. Redundant power supplies plugged into separate breakers with battery backup on both. Because if you've got two power supplies, but they're plugged into one breaker and the breaker fails, guess what? your second power supply accomplishes nothing for you. You're still down. And ideally, each of those will have a battery backup so that if your site is without power for any length of time, you're not down. Because again, even if you're on separate breakers and the power to the building is out, you're down. Your redundant power supply didn't do anything for you. I'm going to get redundant with the word redundant here, redundant storage, even redundant network, because those are also things that can fail and cause outage time. So one of the things I'm pretty passionate about, and my colleague Art Cagle is also kind of passionate about it, is redundant dedicated storage. And we're not talking about like a SAN with, RAID 5. We're talking about a dedicated storage unit with full mirroring. You can do some striping, and it can increase your speed at a cost, at a performance cost in particular. Other costs as well. Parity RAID modes like 5 and 6, those I'm not real fond of. I know a lot of people swear by them, but they cost you performance, especially in the event that you lose a drive. And they're just, they're a lot more reliable than they used to be, but I still am not a fan. And these days, storage is inexpensive enough that you should be able to justify the extra cost of full mirroring. Of course, a RAID array doesn't do any good if the RAID controller fails, so you have to have redundant RAID controllers as well. And ideally, those redundant RAID controllers will have dual paths to disk. That means that every disk in the system can be accessed if the RAID controller fails. A lot of systems will have redundant RAID controllers, but you'll have some RAID stripe sets or mirrored pairs on one controller and some on the other. And if you lose one, you still lose a bunch of your disk, and that's not bueno. The dual paths to disk also gives you some performance benefit because your throughput is effectively doubled. You don't have to worry as much about the controller itself being a bottleneck. And again, I say this again, no shared storage if you can help it, because a SAN, even though it's like designed to be redundant and all that thing, the SAN itself is also a thing. And this is where I have a little fun with it. I go to what I call my true Girschywood stories, incidents that have actually happened in my career that I've had to deal with, usually under a lot of pressure and scrutiny. It was back when I used to work for a major hotel chain. We had at the time, state-of-the-art EMC storage array that we used for all of our enterprise storage. And it wasn't just redundant, it was triply redundant. So you had, for every basically mirrored pair was a mirrored triple, a set of 3 disks. So you could lose a disk, you could lose 2 disks in a mirrored set and still not lose any data. It had 3 power supplies, it had 3 controllers, it had 3 everything. And it had phone home capability. So it would, if something failed, it would just send a message, and within 4 hours, somebody would show up with a part and it would just magically heal itself. So clearly this is never going to fail on us. Obviously not. Well, it was a Friday afternoon, because of course it was, about say 4:30 in the afternoon. A lot of people had already left for the day, including a couple of key people who had left for the weekend, for a long weekend for vacations. And abruptly, our entire enterprise storage went down. And what happened? Well, what happened is we lost a power supply on the SAN. No problem. It phones home and says, all right, I need a new power supply. Somebody within 4 hours come out and replace the power supply. Before that 4 hours was up and the replacement power supply got there, a second power supply failed. Now the SAN is down to a single power supply. And the logic of the SAN said, you know what? If I'm running on one power supply and something happens to that one remaining power supply, now cache is lost. We're looking at potentially losing data, and I'm not going to allow that to happen. So I'm going to gracefully shut down the entire SAN, which it did, and yanked the storage out from under our entire enterprise. And we were down for a period of hours until those power supplies were replaced. So even though we had this massive triply redundant SAN, that SAN still proved to be a single point of failure. It failed, and it took out the entire enterprise. Now on to network. 2 NICs, 2 ports on one NIC won't help you because that NIC is a thing, And if the NIC fails, both ports fail, and you're no longer connected to your network. Again, added advantage, better throughput, because you can actually spread the traffic across both of those NICs. What we use in my current enterprise is a concept called network teaming, where each NIC in the system is connected to a separate switch, because the switches are also things and a switch can fail. Both of them listen on the same address. So you have two network cards connected to two switches listening on the same IP address, which sounds like a recipe for trouble, but the driver handles the duplicates. It works out. So what it does is it just throws out the duplicate packet if it gets it. Now, if a network cable, a switch, or a NIC dies, your system is still connected to the network and it can still communicate. And again, if you configure it in either round robin or load balance mode, that team, you can effectively double your network throughput, because each NIC can handle the full, in our case, 10 gigabit now of traffic. So normally I would ask for questions so far, but unfortunately, as I mentioned earlier, just like I said, put them in the chat and I will see them at the end of the presentation. So now that we've built a redundant server, what if the whole server fails? What if there's a power surge and a massive catastrophic failure, non-recoverable CPU failure? What I like to call the ID10T error, the drastic error that somebody just pulls a stupid. We actually had someone, and a couple of employers ago, we had somebody that walked by and simply unplugged the wrong machine from the wall. Just took our production server down by unplugging it. That's the classic ID10T error. So the solution to this is to get a second identical server, and ideally you put it in a separate rack. You connect it to its own set of separate switches, which are on separate power breakers with its own storage. And you can see how this gets exponentially more expensive. So now you've basically got 4 of everything in a sense. You got 2 servers with double everything in each server. It's important here, and we'll cover in a little bit, that if possible, these be physical hosts rather than virtual machines. And super important is that each server in this topology is shared nothing, because once you share something, that thing that's being shared can be the thing that fails and the thing that hurts you, bites you in the butt. So why not virtualize? Well, the VM incident, I like to call it. A few years ago, we had a bunch of servers on VMs on a virtualized cluster, and the hypervisor had an issue where, for some reason, if everything in the VM, everything in that cluster is effectively sharing the same network infrastructure and network backplane. So your VM cluster is a bunch of nodes that are all on a common backplane that has a couple of NICs. If for whatever reason this particular hypervisor in this version lost connectivity to the network for more than about a second, it would panic and it would reboot every single VM in the cluster, which happened in the middle of a day on a business day. Because of everything that I've said before, my database servers were not affected because they were on their own dedicated hardware. But we lost a lot of important VMs. We had a lot of systems that were allegedly redundant, but they all lived on the entire on the same cluster, and that cluster was a thing, and that thing failed. Things fail in unexpected ways. Everything came back up relatively quickly and relatively gracefully, but we had a panicky 20 or 30 minutes while we figured out what the heck just happened and how to make it happen again. How to not make it happen again. And so what I wanted to point out here is that if you do virtualize, because a lot of people don't have the option to do dedicated hardware, what you want to do is virtualize into multiple clusters. So I have, say, instead of a cluster, I have 2 clusters that don't share any hardware. And then I split my systems across those 2 clusters so that even if one cluster fails, there are VMs on the other cluster that can pick up the load while the first cluster recovers or somebody intervenes. So you've got redundant servers. You've got redundant components within the servers, but now you have to put them behind redundant connection routers, because on the Informix side, we call it the connection manager, but various platforms have different ways of routing clients. And you set up the connection manager so that in a primary, secondary topology, clients know which server to go to, and they don't, you don't have to program any logic in there. It just goes to the connection router and says, hey, send me to the primary, and the client knows. But if you only have one of these, that connection router, connection manager, is now the single point of failure, and it can die. You should not put your connection routers or connection manager on the same host as the DB, because you've just undermined a bunch of redundancy. CMs or connection routers can in fact make sense to virtualize, and in fact we do in our enterprise. But the CMs, as I was just talking about, should be on separate VM clusters, because that VM cluster is a thing. That thing can fail. And if the cluster fails and all of the VMs are on it, or all the CMs are on it, you now no longer have clients able to connect into your database, even if your database is still up. With multiple connection manager connection routers, however, failover becomes an issue. On the Informix side, you need to make sure that each connection manager has a unique priority value. And if you have multiple CMs that can talk to the same host or VM, only one should have failover enabled. What do I mean by that? In the Informix side, suppose you have a single database engine that has multiple listeners, one for SSL, one for open connectivity, for example. We have one that listens on an old protocol for legacy apps. And we have separate connection managers for each of those protocols. You only want, even though they're all connected to the same one, to avoid confusion, you want to make sure that only one of those connection managers has failover priority, or one set of connection managers has failover priority. The other one should have it disabled, so that you don't have them stepping on each other. And it also makes it easier to keep the priorities unique among them. So far review. Internally redundant hosts with redundant power. Each of them is connected to dedicated redundant storage. Each connected to redundant switches with redundant cables from redundant NICs behind redundant connection routers running on redundant hosts or redundant VM clusters. What are we missing? That seems pretty good. What if the entire data center fails? The data center is a thing, and that thing can fail. Lightning strike, catastrophic weather event, power failure, again, the ID10T error. So, solution to this, second data center, preferably identical or as close as you can get it to be, and you repeat everything that we've done in the previous steps at a second site. So now, either site can be your primary site if necessary. Also, redundant connections between those data centers, because you got to keep things in sync between the two data centers. And if the connection between them fails, now what happens? Now you get a site out of sync. And location matters. If you have two data centers down the road from one another, even just a state away, I guess it was only 10 or 15 years ago that we had a major power event in the Northeast, and there were multiple states without power. And if both data centers are within that region, your entire enterprise is down, as opposed to just whoever's within that region without power. Same thing can happen with a catastrophic weather event. It tends not to be all that localized. A huge blizzard, for example, that knocks out power. So the location of where your second data center is hugely important. So now, internally redundant hosts, redundant power, dedicated redundant storage, redundant switches, redundant cables, redundant NICs, redundant connection routers, or redundant hosts or VMs, redundant data centers in sufficiently distant locations. This has got to be good enough. What are we still missing? Well, the WAN incident. We had an incident where our data center lost its connectivity to its primary WAN. No problem. We have redundant connections, redundant WANs with redundant power, except for whatever reason, the failover that the data center provider had in place didn't actually fail over. So we actually not only had a second switch, but a third switch, and third network. And we had to ultimately, while the data center figured out what was going on, we were manually failing our systems over to a third network provider. So your failover is only as good as your ability to actually use it when you need it. And this is what happened here. We didn't get that. So now, you have to find ways to test your failover as well as have it in place. to make sure that when things get really important, when it happens in real life, you're ready to go and you know what to do. So as I just said, it's only as good as your ability to use it. Can you successfully fail from one host to another with minimal interruption? Can you fail from one data center to the other with minimal interruption? And the more you obscure all this redundancy from your clients, pardon me, users, customers, the better off you're going to be. They shouldn't know about it. They shouldn't care about it. This is a back-end thing. If you fail anything over, they shouldn't have to change anything. They should just connect as they always connect, and connection routers handle it, or, there's the infrastructure behind the scenes handles their request, and they don't have to change anything other than maybe might have to disconnect and reconnect. So here's sort of an overview of what I've just described in detail. We have our primary data center on the left and our secondary data center, or our DR data center, disaster recovery data center, on the right. And from the Informix perspective, we have two connection managers on each side of the line. We have a primary and a secondary server, HDR primary, HDR secondary in the primary data center. The second data center has two RSS servers, two DR servers. One of them is intentionally kept on, depending on the system, a 12 to 24 hour delay. We jokingly call it the time machine. So that suppose, your data is redundant, you're fine, but suppose somebody deletes a bunch of data they shouldn't have. Now I've got a server that's 12 hours behind, and I can go back and get that data as long as I catch it in time without having to do a full restore to recover that data. So that's what we're doing. We're looking pretty good, right? Not quite. Next true Girschywood story involves automated failover. We had an event where the connection between the two data centers that I just mentioned was lost. And so no problem. We got automated failover. Everything kicks in. Everything was good within the local data center. It was the remote one that was the problem, except it didn't work quite so smoothly. We wound up, because of how things were configured, with what's called the split brain, which is why you see this image in front of you. We had a split brain problem because data center A, everything was fine, nothing happened. Data center B went through its failover steps, said, oh crap, I can't see data center A anymore. So I guess I better make myself primary because I'm the only one that's left. So here's how it works in the Informix world. The highest priority connection manager wins. It's considered the failover arbiter. And if the highest priority CM loses contact with the primary, it checks the secondary. If the secondary can still see the primary, fine, doesn't do a thing. If the secondary can't see the primary, that connection manager will now promote the secondary to primary. If it can't see the secondary either, it works its way down the nodes in HAFOC order in the config file. So you can specify an order, okay, try and share disk secondary first if you have one, full HDR next, RSS next, and so on. You can actually set that order. So far, so good. But again, in the case we just talked about, what happens if you lose your data center link? Well, I'll walk through it. Again, as I said, data center A on the left, everything's fine here. Data center B, not so much. We got two servers over there, two connection managers. They can't see the primary. They can't see the secondary. So what do? In data center 2, here's its view of the world. All contact to data center A is lost. So CMB1, that connection manager, is now the highest priority among the connection managers it can see. It can't see the primary. It can't see the secondary, but it can see a local RSS. Now it goes through its questions. Can you see the primary? And the RSS said, nope. And so CMB1 says, well, guess I better initiate the failover. So the node B1 over here, the DR node, formerly RSS, suddenly becomes a primary. And now our view of the universe looks like this. I have two primaries and two data centers, and a secondary in one and a DR server on a delay in the other. And now we have a split brain. If I have clients connecting to both data centers, now I got a problem because my data is getting out of sync. And that's nightmarish to recover from. So this is a situation you want to avoid at all costs. And so how do you get around this? Unfortunately, there's not an easy, straightforward way. The way that I got around it in our enterprise is we only enable automated failover at the primary data center. And so if something goes wrong at the secondary data center, it will never fail over. What that means, though, is that if we have to fail over, if the full data center actually fails, the primary, and it's not a connection problem, then we really do need to fail everybody over to that second data center. And that means that step becomes manual. Is it possible to do it in multiple data centers with auto failover enabled? Yes, it is, through a combination of either workarounds or product enhancements that I've been asking for. But I want to move on for a moment to management issues, because I mentioned that it gets a lot more complicated and you've traded one set of problems for another. So are your secondary and disaster recovery servers actually ready to become primary? Are all the appropriate user accounts set up? Are all the necessary scripts present? Are all the cron jobs configured? Are they set to run only on the primary when appropriate, because you don't want them running on multiple servers? Do the configurations match, both in terms of hardware and software? You need to have a set of procedures in place to ensure all of that, so that if I update, say, for example, a cron job on one server, I got to update it on all four. If I create a new user account, I got to create it on all of the relevant hosts. Any kind of configuration changes like that, if I modify the buffer pool size, for example, I got to make sure I do it on all of the hosts. So you need to make sure that you're keeping all of that stuff in sync, or otherwise, when you fail over, you might find yourself back to a problem that you thought you solved because you only solved it on one machine and the other ones don't have that solution. So how do we fix the problem of multiple data center failover, for example? How do we resolve a lot of the issues we see? Well, the answer comes in threes, or really odd numbers. Using a couple of other platforms that we have in our enterprise as an example, MariaDB is one, MongoDB is another. They don't actually use priority to determine failover. What they do is use a majority vote algorithm. So if you have at least 3 nodes and an odd number, failover will only happen if the arbiters, whatever they might be, a majority of them agree that what was the primary no longer should be, and we need to make a switch. So ideally, this gives you a third data center even. So in 2 data centers with 3 nodes each, you have 6 nodes and there can be a tie. If you have 3 data centers with 3 nodes each, that'll work, but that's kind of overkill. So from the MariaDB, MongoDB view of the world, what you do is you have 2 data centers with 3 each, and then that third data center just has 1 node that acts as like a tiebreaker arbiter, and you don't have to fully build it out. On the Informix side, because it doesn't do the majority rules thing behind the scenes, you really only need 2 in each data center plus 1. So you're looking at a 2 plus 2 plus 1 configuration. And so that looks something like the graphic we initially showed you at the beginning of the presentation. So in our example, let's talk about a main office that is not really a data center. I just have a connection manager sitting in the main office where most of the employees are working. I have 2 data centers that are both remote. The connection manager that's CMC1 here acts as your failover arbiter. So it can see both data centers. It can decide what needs to be failed or not. Now, let's talk licensing. All that hardware is already expensive, but now we have to license the software. And per the IBM license agreement, you must license any engines, and this is limited to Informix. I don't think other products work this way. So be sure to check with your sales rep. Be sure to check contract to validate this information. Very important. Per the IBM Informix license agreement, you have to license any engines that take user transactions. So users are connecting, users are getting data, bulk jobs are running, that kind of thing. If no users connect and no work is done, that is, it's a true DR server, it's just sitting there as a warm standby, receiving data, data updates, receiving replication, but you're not running reports off of it, you don't have users connecting to it, you're not running batch jobs on it, it's just sitting there in case something goes wrong. For those servers, you don't have to license them. So the question becomes a balancing act at that point. What's more important to you? Do you want the ability to distribute your workload across those machines? Or do you want to keep your licensing costs down? Because you have to pick. In our enterprise, we have 4 servers. We use 2 of them. We license 2 of them. So we have a read-only reporting server, which is our HDR secondary. And of course, our HDR primary is taking the transactions and doing all the work. So Once again, eliminate single points of failure is the mantra. We've still missed one at least. And that's in a smaller enterprise, could be you. That's me when I had hair. Yeah, it's arguably the most important single point of failure, because if you've got one system engineer or one network engineer or one DBA or one person that's filling most of those roles, and that person abruptly quits or gets run over by a bus, is the famous example. What do you do at that point? How do you deal with that? So depending on your enterprise size, you want to make sure that you have multiple people who all understand, at least at a basic level, how the stuff is set up and how it works. Important to have good documentation of how all that stuff works so that someone can come in. And if you're not of a size that allows you to just have multiple full-time people, there are several good companies that are doing remote DBA service, remote system administration service, and you should look into that and see if that fits better into your company's price range. But the last thing you want is for some idiot like the guy in the picture here to just walk off, and now you're left without somebody who understands how the enterprise works and how to keep it up and running. And that's it. So now I'm going to jump back in and I'm going to start reading our questions here and see what there are, if there are any. And no questions. Excellent. So I'm going to give you maybe a couple of minutes here just in case you want to ask additional questions. Otherwise, thank everyone for coming and hope you all have a good day. Okay, going. I see there are a few of you are still here, but I don't see any questions. My email was at the beginning of the presentation. Feel free to contact me if you have any questions. I'm happy to answer them after the fact. Otherwise, I'd like to thank all of you for coming and hope you all have a good day.